welcome to today's session. This is one of our talks in data that are really centered around thought leadership in the space. This is not going to be a very, Sundeck product pitch. So you're not coming here and just going to be pitched a whole bunch of product. You're going to get more thought leadership in what is happening in the data space by someone who's been very active in the data space from a commercial perspective, but also from a open source perspective as well. And the presentation today, I'm sure you've already seen the title as we signed up, but it's one that's very top of mind for a lot of people, and it's raising some very interesting questions in terms of what is going on and why is there so much interest around certain topics at this point. Today's session will be recorded and we will be making it available. So if there's anyone on your team that you think might have benefited from this session today and wasn't able to be here, that you can share it. And also if you want to come back and watch it again, you can definitely do that. We do have a Q&A, so that will be available. Hopefully you can type your questions into the Q&A. If maybe someone can just put in any question, a simple question, what day of the week it is, anything, just to make sure that we've got that working, we can see everything coming up. That would be fantastic. And then we shall go ahead and kind of get started here. So if we can move to the next slide, Jacques. We're trying to make these as interactive as possible. However, I do believe that the chat is not available for everyone. I did try to open it up, but it seems on the webinar for Zoom, unable to do that. But definitely I made the questions open. So if anyone asks a question, you can upvote the question with the thumbs up. And you can also, you can type answers. We invite conversation to happen, and we will be addressing those questions as well as we go through. So without further ado, I'm going to hand over to Jacques, and he's going to take it from here on today's session.
Thanks, Matthew. So I have sort of a sub-headline here, which is that what's the future of data platforms? Where are we going? And I think, let me first just talk briefly about myself and a little bit of my background. So as Matthew mentioned, I spent a lot of the last 2 decades in data and in open source data. Got involved early in the table formats, was co-creator of a project called Project Nessie, which is actually now being contributed and becoming part of the Polaris data catalog by Snowflake. Early contributor to the Iceberg project. I was also the co-creator and founding PMC chair of Apache Arrow, so thinking about how data moves between different systems. Also the co-creator of Substrait, which is something I'll talk about a little bit later. Been involved with Apache Calcite for a little more than a decade. Early user of that technology, as well as co-creator of Apache Drill. So I've been working in the analysis space for quite some time. On the commercial side, currently CEO and co-founder of Sundeck. And prior to that was CTO and co-founder of a company called Dremio in the data lake space as well. So let me just start with a question that I've been asked a number of times, which is, why did Databricks pay some billions of dollars for Tabular, somewhere between 1 and 2 billions? We don't know exactly. But why is that? Because it's a sit up and pay attention kind of number. And so you start thinking through this process and why this happened. And the natural tendency, and I've heard this from people, is that, well, it's probably because Tabular had a bunch of customers and it was a huge revenue growth opportunity for Databricks. Because this is actually the most common reason that a technology company gets bought, right? Is that you're like, oh, that's a good market, I want to grow it. Well, it's hard to believe that that's the case here, right? For a couple of reasons. One is that, Tabular was about a 20-30 person company. We don't know exactly how much they were making, but let's guess that it was, between 1 and 2 million in ARR. At the same time that Databricks was making billions of dollars in ARR. And so there was no indication that the tabular market of selling catalogs was going to actually be more profitable than the compute market that the Databricks is already in. And actually, to sort of underscore this, their pattern with Tabular is to basically incorporate those things into their free product, which is Unity. So pretty quickly, you can eliminate this as the likely suspect for why they purchased Tabular and spent the money that they did. The second most common reason that people buy a technology is an acquihire, right? They want to acquire the talent. And there's some reason that you could argue for that here. Tabular probably had the largest number of total PMC and committers to the Iceberg project of any particular single vendor. But if you do the math, it's a little tough to believe that this is the reason, because at, let's say, a $1.5 billion purchase, and I think there's 5 PMC members, or sorry, 5 committers. I think there's less than that PMC members, 5 committers that were at Tabular. We're talking about $250 million a person or more. And so I got to tell you that I think most people I know, if you came to them and said, hey, I'll hire you for $250 million, they'd be able to do that. So it can't be an acquihire. So then we get into some other ideas of what this might be. And so one of the ones that I hear from conspiracy theorists is that this is to kill Iceberg. I think that there's some people are scared that, like, Databricks has sort of a mixed past with open source. Sometimes, like, created Spark, which is awesome, everybody uses it, but then kind of held pretty tight control over Spark, which in the later days people got more frustrated with. Delta Lake started as something that was kind of semi-open source and then became more and more open source over time as they were forced by their customers in the market to make it more open source. And so there's a conspiracy that the real goal is basically to kill Iceberg. Well, this is, from my point of view, laughable. And the reason it's laughable is that Iceberg is a name, and it's a concept. And the two are not necessarily tied together. And so what we've seen, I think, better now than ever is that if someone tries to kill an open source project that is successful and has a lot of contribution from a lot of different entities, the project will just fork, right? And so could Databricks convince individual people who worked at Tabular to act as bad citizens in the Iceberg community and disrupt Iceberg? Yeah, that's possible. Although knowing the people that are actually involved, I think that would be very difficult. But there's not a lot of upside. It doesn't make sense to spend $2 billion to do that, because worst case scenario, all of the other people who love Iceberg would potentially just pick it up and fork it and create another thing, because it's an Apache license, right? Apache Foundation does create some protections against this, against the risk that one particular vendor is going to influence something in a negative way. But they've shown that they're pretty slow to counter these things. So that's not as much protection as people would like. But the reality is that it's a vibrant community. Huge amounts of people are very dependent on it. Large enterprises are very much interested in the success of Iceberg. And so it's unrealistic that anybody would be able to kill Iceberg, even if you bought or hired a bunch of the committers through an acquisition. So this is also actually pretty laughable. So then we start getting into things that are actually much more likely. So one of the interesting things to look at is you actually look at the technical details of how Iceberg works and how Delta Lake work. They're not that different. They have a lot of the same ideas. Now, there are definitely tactical things that are different. But one of the things that was happening in the market is that you saw this, what I call the Betamax dilemma, which is that, like, I don't want to pick the wrong thing. And so I'm going to wait on the sidelines until one of them wins. And that was between Iceberg and Delta Lake, right? And this is an interesting dynamic, because if you're Databricks and you want to take on more and more workloads from competitors like Snowflake, you don't want to be thought of as incompatible with Snowflake. And so as much as Databricks always worked with Iceberg and worked with Delta Lake, they pushed so hard on the Delta Lake message that there was definitely a group of people in the market who perceived that Databricks didn't do Iceberg well, okay? And so and if you actually look at the messaging that the Databricks has been focused on with Iceberg and Delta Lake, is don't worry about the details of which one it is, and being able to start to consolidate and sort of combine the two of these things into more of one thing is something that they have more ability to influence now that they have more engagement with the community there. Now, this is something that I think will probably naturally happen over time. And ironically, I actually think this is a good thing for users, because good users don't really need to have to make a choice like this. It's kind of an implementation decision, and people should be able to just use a table format and have that sort of ability to access that data anywhere. So this is one of the things that I think actually starts to make sense, is putting these on a trajectory where they're starting to marry each other, as opposed to being arch enemies, which is where I think that they were previously. On top of that, the next thing is that speaking to that whole thing about like talking so much about Delta Lake, one of the things that hurts Databricks is having credibility in Iceberg, right? If you're always like, oh, Delta Lake is the best thing ever, then if people position those things as competitive, people won't also think of Databricks as an expert in Iceberg. And so one of the biggest things that you get out of having the creators of Iceberg at your company is substantially larger amounts of credibility in what it means, that what your capabilities are around understanding Iceberg, influencing Iceberg, and just being making that be a trustworthy core part of your product. And so this is actually, I think, very, very much likely the case. Now, the last one is actually the most fun. Conspiracy theorists like this as well, is to F Snowflake, right? Is to just get one over on Snowflake. And no one's going to spend $2 billion to do that. But there is some truth to this, right? Because if Iceberg is a Snowflake thing, then it's harder for Databricks to be associated with it. So if you approach this as a zero-sum game, there is some benefit to actually taking this on. Now, one of the interesting things that you could look at in sort of the private markets and the public market is in the time between when Databricks, when the announcement came out that Tabular was purchased by Databricks, and you look at the actual market values of the companies, there's actually more shift in the value of the market, the value of the company of Databricks positive and more negative than what the cost is of this acquisition. And so the public market agrees with you. Now, there's a compounding factor because Snowflake also had some negative press about breach at the same time. So those things are both combined together. But here's the other thing, right, is that the announcement is very, very interesting because the actual deal was largely agreed to several weeks before the announcement. And then the announcement came out the first day of Summit, the Snowflake Summit. And so there was definitely some opportunity there to mess with your competitor and if you approach this as a zero-sum game. So anyway, so there's some interesting different ways to look at this. Obviously, any of these kinds of decisions, it's not any one thing, it's going to be several of these things. But odds are 4, 5, and 6 are the ones that are most influential to why it made sense to make this choice. Now, the specific number is also influenced by competitive behaviors, right? So, you know, the story is basically that Snowflake had a deal done with Tabular, and in order to disrupt that deal, Databricks needed to come in much higher. So that's also influential there. So kind of interesting, but it makes me want to care. Like, I'm like, okay, I care. Like as a user of data, I care. But why should I? Why do I really care about this? Like, it's like, hey, what does this matter to my actually everyday use of data? And I think it goes to talking about data management cost. All right. If you think about your data management cost, there are 3 main components to that. There is storage, like where you store your data. There's compute, like, okay, I'm doing the analysis of the data. And then there's the people who are working with the data, right? And when you look at data management cost, I've shown this as 3 equal size components, but the reality is that it's not at all 3 equal size components. It's actually very disproportionate. And so what's really interesting about things like the Tabular acquisition and Iceberg and Delta Lake is that storage is actually the smallest component of spend against data management. It's actually people that's the most expensive component, followed by compute. And so why is it interesting to try to compete around storage when the big spend is elsewhere? And that really comes from this pattern of lock-in, which is that historically, data is locked in. So you have users that know how to use a particular API endpoint experience, right? I have Snowflake users. Snowflake users know how to use Snowflake APIs. Snowflake APIs run Snowflake compute against Snowflake tables, okay? And so what happened was historically is that you're forced to use an API depending on the specific location of your data, right? And so the same thing, if I'm a BigQuery user, I use BigQuery APIs against BigQuery compute using BigQuery tables, right? And historically, Spark users, Spark API, Spark Compute, Spark Tables. Now, Spark Tables is a little bit less concrete than the others, but the same concept exists. Is basically you have these large barriers between moving data between each of these systems. And so what that created was what I call sort of this matchmaker problem that organizations had, which is that I've got 2 different things that I'm thinking about. One is, where is the data stored, right? What system is the data stored in? And the second one is the team that needs to access the data, what are they good at? What do they like to use? What are they comfortable with? Is it Snowflake SQL? Is it Tableau? Is it Ibis? Is it Append? Is it Data Frame API? And when I was working on stuff, when I'm trying to figure out how to work with my data teams, I kind of always have to think about the overlap of these two things, right? Because that's the most efficient use of people. It's that the data is stored using the API that is the preferred API of my teams. And so organizations, when they were thinking about building their data teams, actually had to think about this decision-making process, right? And so you kind of had three main options of how you approach this. The first is that you say, okay, I'm going to store all my data in one system. I'm going to hire people who like to work in that system, who are comfortable working in the system, who are effective at working in that system. This is very, very hard for anybody more than a small team, because what you find very quickly is that I've got data in multiple systems, and it's just kind of something that always happens. Now, you try to say, hey, let's just make it like there's one gold location for the data. It's very challenging. So what do people do? They often do the second option, which is that they copy data between different systems depending on what people want. So I'm comfortable using system one. Okay, we've got data over there. That's the gold copy. But then I've got some other team members who are really liking a different API. Maybe I like a Pandas API. So we're going to copy all the data to their local machines. We're going to get them really beefy machines so that they can work with large data sets, whatever. And then your third option is forcing people to work using uncomfortable APIs. Right. So say, okay, you know what? I know you love to use a data frame API, but you've got to use SQL inside of Snowflake because that's where the data is. Right. And so none of the options are great. And people are constantly trying to make a decision between each of these three options. And so this challenge around being the storage to API matchmaker as a data engineering lead or data engineering manager has been very, very painful. And so the vendors, the big gorillas in the market, the Databricks and Snowflake, have both come up with their own approaches to this, right? And over the last couple of years, you've kind of seen this bear out. So Snowflake has approached it from a proprietary storage, historically from a proprietary storage basis with cloned APIs. And so you might have seen the news that came out, I think earlier this week, that Snowflake has now GA'd their Pandas on Snowflake, which really is a cloned version of the Pandas API that is a small fraction of what the Pandas API is actually capable of doing. And it runs on top of Snowflake, on top of your Snowflake tables. Okay. And they did the same thing with Spark last year with PySpark. Now, Databricks took the other approach, which was the Lakehouse approach. Let's decouple the storage so that as much as I can interact with the data using my Databricks engine, if Databricks has originally created it, I can also interact with it with other tools because of decoupled storage. And I think the thing that we've seen over the last year, and I would say that Snowflake probably even agrees with this, is that the model that Databricks came up with won, right? And so what you see with Snowflake is you see more and more investment in that ability to have Iceberg and Polaris and these other things to make your decoupled storage a possibility. And so what that creates is it allows people to make more choices. And so what we start to get is what I call data portability, which is that I can use my data in multiple locations without actually having to make copies of it. So portability really means access here, data access portability, right? So my Snowflake users using Snowflake APIs and Snowflake Compute can access my tables, but Spark users using Spark APIs and Spark Compute can also access those same tables, right? And so as much as storage itself is a very, very small component of the overall stack, the spend that it influences is very, very large because people are your most expensive, compute is your second most expensive, and historically they've been coupled to where the data is stored and therefore had a huge influence over the total spend and where you spent that money. Now, that's all where we kind of are today. What's next? So the war is only beginning on this stuff. And so we're in the waning battles of table formats, right? And that's kind of where this fight has been for the last few years. Is it Iceberg? Is it Delta? And there's other technologies like Hoodie and Paymon and whatnot. Like there are other technologies as well, but for general purpose, it's generally been between Iceberg and Delta Lake. What we start to see now is what I would call the catalog wars, right? So, hey, should I use Unity or should I use Polaris? Now we're in the initial skirmishes for that. You'll see that fight go out over the next few years between Databricks. And it's another way for Databricks and Snowflake to fight, right? They first fought about just performance and benchmarks. Then they fought about which table format's better. Now they're going to fight about which catalog is better. And that's part of that whole game. But all of it is about compute spend. It's about the engine, because all of the money that these vendors get, right? They're not professional services companies. They're not consulting companies. So they're not going to cut into that, a huge amount into that people side of the data management spend. What they're going to be able to do is focus on that compute spend. And that's where they really, really want to get as much money as possible. And that's really the final battle. All of these other things are just proxy wars to that. Now, what is interesting about this is that we've been going through this process around data and trying to and achieving data portability, right? And that really started with a standardized file format. It was some Orc, some Parquet, but ultimately I think Parquet won there. And then we started to have the table formats, which allowed you to have table access. And now we're talking about the catalogs. All of those things together basically just give me data portability. As a data engineering person, you shouldn't care that much about the names in the boxes. What you really care about is data portability and how data portability can impact your business. And there's going to potentially, in the future, there's going to be different names in those boxes, and that's all okay. But basically, we've been moving up this stack of maturity and accessibility, right? As the technologies get more mature, they become easier to access. And that's what we're seeing is that more tools make it much more straightforward to interact with these things. And that's been really, really great. Now, the second thing that's been happening, and I think this is something that is not talked about as much, because most of the interaction has been happening in the database builder community, is that there's also been a similar stack being built for compute, okay? So everybody's been focused on data portability, but the interesting game is actually going to be in compute portability, which is moving along at a slightly slower rate. So it's not as mature as data portability, but that stack is about basically allowing you to move where you're going to, how I want to put my compute. Do I want to put my compute over here, or do I want to put my compute over there, right? And so core components of that was Apache Arrow launching nearly 10 years ago. And then you have technologies like Velox and Data Fusion and Substrate that were built on top of that. And so let's talk a little bit about this compute portability stack, which is something that people haven't generally been talking about, but is actually the thing that's going to change the next 5 years. And the compute portability stack is built around a standardized representation of data, which is Arrow, okay? I don't think that there's really any competition around this, partly because Arrow is open and everybody can use it. There's no monetization there. Then you have high performance compute kernels. And some of you may know some of these names. I'm sure a few of you know all of these names. Some of you probably have heard of none of these names. These are different technologies. So Velox is a technology that came out of Meta, where they basically were like, I want to make a faster compute kernel and I want to use it in multiple systems. Data Fusion came out of the Arrow community. It's a Rust-based kernel for doing high-performance computing. DuckDB, I think probably everybody's heard of DuckDB. It is a powerful, multifaceted capability, but one of them is that it is a compute kernel. So I can take DuckDB and I can run stuff on top of it. And then people also have been using ClickHouse as another high-performance compute engine and kernel, and specifically CHDB, which is an embeddable version of that. Okay, and so that's the second component. So you've got the standardized representation of data. You've got a set of compute kernels. You can use one of these, more of these. And then the last thing that needed to exist was a standardized representation for instructions. Because what actually happens in these systems is that you have whatever API at the front, right? Whether it's a data frame API using IBIS or a SQL API or the Spark API, Spark data frame API or whatever. All of those APIs get converted down to a set of instructions. And interestingly enough, across all of the systems, those instructions are very similar. And so we wanted to have a standardized way to represent those instructions. And that's what the Substrate project is about. So compute portability is about same API, same data, different compute, right? So right now, if I want to use the Snowflake API, I use the Snowflake compute. But now I'm starting to be able to use data that exists inside of Iceberg or Delta Lake, and not just data that exists in the proprietary Snowflake tables. Same thing if I want to use Spark APIs today, I use Spark APIs that works with Spark, and then Spark interacts with my underlying data. So I'm sharing the data, but I'm still coupling my APIs to my compute. Well, what you may not realize is that there's already been a huge amount of progress in this. And so if this comes up here in a second, there you go. So there are several companies that have actually already taken original platforms and recomputized them, like shifted the compute from one engine to another. And one of the first to do this was actually Databricks. Databricks said, hey, we can run Spark jobs on something faster, Photon. And so from a user's perspective, I'm using Spark, but behind the scenes, I'm getting more efficient. Microsoft did the same thing with Spark, building Fabric. Fabric is a combination of gluten and Velox to run Spark jobs. Okay, much more efficient, but from a user, you don't really need to know that. It's an implementation detail. Okay, AWS is doing something similar, right? So the Redshift team is building huge amounts of technology. It's the largest team in the analytics community inside AWS. And they are building faster and faster high performance compute. And they're not only using that for Redshift, though, they're also starting to use that for things like Athena. And so this idea of basically saying, I'm going to shift things over, Meta also did this, right? So Meta was like, hey, we have huge amounts of Presto and Spark jobs. There's a huge legacy there, and most organizations have this. Those tools have been around for a long time, whatever it's, whether it's Presto and Spark or Spark and Snowflake or whatever. These tools have been around for a long time. You've built up a huge amount of workloads on these tools. It is not realistic to try to figure out how to rewrite all those applications, right? The people who built those things may not even be there anymore. You may not know, you might not have tests to know whether or not if you changed it, whether or not it would be reliable. And so what they did is they said, we're going to actually take those things, keep those APIs the same, but we're going to build a Velox, which is a high-performance compute kernel, and we're going to make it work for both of those things. And what you start to see here is this disconnection between what the API is and how the work actually gets done. So portability is already happening. Right now, though, it's something that, generally speaking, you've got to have a huge budget to do, okay? And that's what's going to change over the next few years, is that portability is going to become something that is available to everybody. And when that happens, that means that you're going to be in a situation where you don't have to worry about storage matchmaking anymore, where when you pick what you're going to work with in terms of an API, you pick it because that's going to be the most efficient way to interact with that data, right? Like that's the best metaphor for that kind of data. That's the most comfortable metaphor for the users that are actually working with that data. You're going to have your gold data in your standardized table formats, right? So it's going to be accessible from a large variety of different places. And then you're going to pick your compute based on what is the SLA criteria of that compute, right? Like how performant is it? How efficient is it? Can I make it run on my existing infrastructure that's idle? Do I want to use it and just pay per individual operation because that fits the economics model of what I'm trying to do because it's an external report, whatever the case may be. And so what happens is that you basically have API, storage, and compute all as independent decisions, and that allows you to achieve the best of each of those worlds. And what we call that at Sundeck is the fairhouse, right? So we went from warehouse, where you have a monolithic system, typically on-premise, that includes actually the hardware. We then went to software warehousing, right? Then we went to SaaS warehousing, right? Like Redshift. And then we went to storage disconnected compute warehousing, like Snowflake. And then we went to Lakehouse, right? And Lakehouse is, hey, the data is something that's accessible from multiple places in a standardized format. The step after that is I can now independently choose that API level as well as the compute level. And that's what we call the fairhouse. And this is the picture, right? Is that you continue to have your Snowflake users continue to use their Snowflake APIs, your BigQuery users use your BigQuery APIs, your Spark users use your Spark APIs, your Pandas users use your Pandas APIs. But what happens is that you have a abstraction that allows you to standardize that compute, extract the compute, and then execute that against whatever makes sense for you as an organization against that shared storage layer. So you basically have a shared abstraction to compute and a shared abstraction towards storage. And this is where we believe the market is going. And so for you as an organization, how do you plan for that future? Well, the first thing I'd say is that, if you're not using table formats today, start using them. Your future self is going to thank you for them, for that, because it gives you choice, right? Because as much as storage is not a big spend, right? We saw a picture at the beginning. Storage is not a huge part of your spend. So you might think to yourself, why do I care whether I use a table format or proprietary storage or whatever? You don't use table formats because you want to save money in Snowflake. Nobody spends a huge amount of money on Snowflake storage, or very few people do. You want to use table formats because it's going to allow you more choice in the future, okay? The second thing is start to shift how you think about your organizational roadmap, right? Try to get to a place where you stop categorizing tasks by where the data is stored, right? And maybe you're not doing that today, but just because you're copying everything everywhere, right? But hopefully in the future, you can continue that process without actually copying anything, because we all know that copies are expensive, they're hard to govern, et cetera, right? and really start to think about like, okay, let's focus on using the right tool for each job. Let's pick on an API based on our team skills, and really focus on that, and really get ready for engine choice, which is really where I think that the whole market is going. Now, this is something that's about the future. It's not about today. It's not like I can go and do all of these things today in these tools without a lot of my own work. But this is where we think the market is going. And what you can do right now is start to get yourself ready for it. And the first thing is to start using those table formats, because that's the first part of this. If you don't have, if your data is locked into one technology, you're not going to be able to start to take advantage of all of these advanced capabilities. So that's all I have. I'm happy to answer any questions if there's questions, people.
Great. Thanks a lot, Jacques. That was super informative. I'm sure everyone would agree. Just to let everyone know, I know you probably have a lot of thoughts. You're listening intently and not wanting to write questions and miss something. So go to the Q&A section at the bottom of your Zoom section there and put in some questions. You can read other people's questions, you can upvote them, and also you can comment on them as well. So we encourage free conversation. The chat is open to talk as well. We want to make this as much as a community feel like we're in a room together as possible versus just a broadcast. So please do engage. That's where I think this gets interesting. And with that, we do have some questions. So I'll read them out for the benefit of people listening. Let's start off with this one. This one's quite interesting, given just the last few slides that you show, Jacques. And it's Victor's asking, why would vendors, Databricks, Snowflake, etc., be interested to invest in a fairhouse if that will make them replaceable?
So it's an interesting question, right? I think that the reality is the other way around, right? Which is that Databricks wants Snowflake's compute, and Snowflake wants Databricks' compute. Okay. It's true that Databricks doesn't want to give up their compute to Snowflake, and Snowflake doesn't want to give up their compute to Databricks. But all of those organizations had mega growth, right? And the market is going to punish them if they can't continue to maintain a high growth rate. And as they get to a point where they're starting to tap out on their ability to grow within their existing segment, they're going to look at additional segments, right? So if you actually think about it, Snowflake and Databricks are similar, but not exactly the same, often bought by slightly different organizations most times. So organizations have both of those things. But in both of those organizations, what they're trying to do is say, like, I need to take more Snowflake customers, right? And you can take a certain number of Snowflake customers by migrating them onto Databricks. But as I get to more serious levels of wanting to get more and more of those customers in that workload, I've got to figure out a better ways to do that to make it easier for people to transition over, right? So nobody is thinking that, everybody thinks they have the best engine, right? It's great. When you ever talk to a company that's building compute engines, they always think that they have the best compute engine. And, you know, each of them do in certain ways. And so they're like, yeah, I'm not worried about people moving off my platform because my compute engine is the best compute engine, right? I've got the best ecosystem around this thing, and I am going to be able to take more than I would lose. Now, that being said, they're not going to invest in trying to make it so that it's easy to run Databricks jobs on Snowflake. You know, Databricks is not going to invest in trying to make that happen. Of course not, right? That's what Snowflake's going to invest in, right? You see that already with Snowflake investing in several layers of this, right? So everybody's investing in trying to take compute onto their platforms, not give it up. But what that creates in an ecosystem is investment in the ability to make compute itself portable, right? Which is, to me, is the benefit. Like, companies are not out to like help people largely. They're out to help themselves. And what we're doing here is we're saying, you know what, actually, as part of that, what's going to happen is that people are going to get helped because we're going to have compute portability. Right? Like, and to me, the Delta Lake and Iceberg is exactly the same thing, right? Like, why did Databricks buy Iceberg? Because they want Snowflake workloads, and Snowflake is Iceberg, right? Conceptually, right? From a market perception perspective. And so they want to go and get those workloads. And so they're going to do everything they can to try to make it easy to move those things over to Databricks.
Great. Another one from Sriram. So maybe you can give a little bit of Substrate, a little bit of a glimpse into Substrate in a little more detail, but he's asking, is Substrate some representation that merges, say, a calcite plan of a hash aggregate and a catalyst plan for hash aggregate into a common term?
Yeah, that's a good way to think about it, right? Is that at the end of the day, right, everybody pretty much comes from an algebraic perspective of how to attack data processing, right? And so we all talk about hash tables and hash aggregates and joins and those kinds of things. And all of the systems have those concepts. They might call them something slightly different. They might have slightly different properties for how they behave or how they're optioned. But they all have these similar concepts. And so, Substrate as a technology is something that's already been integrated with Spark Catalyst plans and Calcite. And yes, it does map between hash aggregate in one and hash aggregate in the other. It already works with IBIS, and IBIS matches, IBIS has its own concepts of algebra, but those can be mapped to Substrate, and Substrate can then map those things down to Velox, right? So as a concrete example, right, Microsoft Fabric is built on gluten, and gluten is built on Substrate. And so in order to get a Spark plan and convert it into a Velox plan, that moves through the Substrate representation in order to achieve it.
Right. Jason raises an interesting question here, specifically around Microsoft, one of the big vendors in this space too. To your point about being locked into one vendor, engine, etc., there appears to be a friction between Microsoft Fabric and Snowflake. Microsoft appears to be pushing Power BI Fabric functionality, and if Fabric imports data from Snowflake. Question: how do you balance not being locked into one technology/vendor versus engine sprawl?
That's a great question. It's a really interesting question, right? Because it's the next level question, which is like, okay, let's say that we have we have compute portability. What then? Like, do I have to worry about working with 12 different engines? No, I think in the early days, maybe you will have to worry a little bit about that. The question is, do you care where your compute runs if it's trustworthy? This is, to me, is the key question to ask, right? Is that like, if engine sprawl is a giant maintenance nightmare and a governance danger, then that's a big problem. If I can use 10 different engines, but I don't really care about the details, and I use only a selected set of engines that are trustworthy, right? Like I know that these are things that I can trust my data going through. And that is an abstract decision based on choice or based on performance needs or efficiency or whatever. Is it a problem, right? Like that's actually to me is the interesting question. Like right now, engines are heavyweight, conceptually speaking, heavyweight things. There's a lot of decision making that goes into those things. But if we achieve compute portability, then engine choice should be something that's actually a much lighter definition. Now, that being said, I think that there's an opportunity for there to be abstraction layers to help manage that. But the thinking I have is that we are going to get to a place where choosing one thing versus another is not the choice that it is today in terms of like the level of challenge and pain that you're going to have to consider.
Great. Gregory asked a question: is there a thing that can automatically route queries between different compute based on $config iset? David made a comment then that that's the glory of a composable data system. You can create an intermediate system that can look at the incoming plan and pick the compute based on cost, backend availability, and many other factors. It doesn't matter what the plan format is, but Substrate is a great choice here.
Yeah, and I'd say that that's absolutely true. So I'd say, is there something that's in the market today that allows that, to Gregory's original question? No, there isn't. That being said, there are many companies that are larger companies that are already doing this, right? And I gave some examples of people who are doing it mostly at the vendor level, but actually a lot of large financial services have done this for many years, where they basically say, I'm going to create an abstraction layer that sits in front of my compute and makes decisions about where that should run. And that's really where we think the market is going, and that's where we plan to go as well.
Great. Here we have a question from Anders. Anders, how do we expect existing data warehouse market leaders to respond to the commoditization of compute? What does the result of their strategy look like 2 years from now? Even if Snowflake understands they will have to give up some compute revenue, I still don't see that incentivizing them to make their platform more compatible, e.g. accept Substrate plans, is going to really be a way for them to go. So what do you think they'll be doing to stay relevant?
No, it's a good question. I think, so this is, I've got a lot of history on this because it was an interesting conversation in Arrow days as well. So when we first launched Arrow, right, nearly 10 years ago here, people were like, why would anybody use this? Like everybody's going to have their own proprietary internal format and they're going to use that. There's kind of two phases to this kind of thing. The first is compatibility or adapters, right? And so when Arrow first started, people didn't change their internal format. They had their internal format, and then they would, at the edge, they would convert into Arrow because Arrow gave them access to other ecosystems, okay? But it was generally people, technologies, organizations that were not in the primary position of the market, right? It was people who wanted to get a leg up on the primary competitors, right? The gorillas in the market were, in Arrow's case, the last to adopt, right? I'm not even sure how much Oracle, for example, uses Arrow today. Now the gorillas have changed over time, obviously. But what happens is that basically is you start with adapters for people who are hungry to get a leg up on the incumbents, okay? And I expect very much the same thing to occur with Substrate, which is that you start out and it's going to be adapters against the incumbents, because incumbents are not going to adopt this stuff directly. It's highly unlikely. It's going to be adapters into the incumbents. It's going to be everybody who's hungry to beat the incumbents that's actually going to use these as a leg up to compete. And so we see that in Arrow today, right? So when it started out, it was adapters. And there were no systems that, I mean, Drumeo was a system I was working on. We were using Arrow internally as a representation, but generally speaking, organizations weren't building on Arrow as the core technology. Now, if you look at Velox and Data Fusion, they both use Arrow as an internal representation because it was a way to get a leg up to build those technologies more quickly than starting to build everything from scratch. And I think that's true with Substrate as well, is that today you're going to see more adapters, and that's what we do see. But what you're going to see tomorrow and in the future is you're going to see people who actually, once this becomes a more common technology and it gives you connectivity and ability to build something more quickly, you'll start to see people who actually build it as the core way to represent what they're thinking.
Sriram's asking, how does Aerofly fit into all of this? And does it help and rescue any of the abstracting compute?
Yeah, I think it's a good question. So, so one of the things that we've talked about that I proposed in the Substrate community is something called Substrate compute service, which is the idea of packaging something up to be able to interact with it in a standardized way, right? Because as much as like Substrate itself is a representation of instructions, it is not a protocol for communication. Like I said, it doesn't have a network protocol or anything like that. Aeroflight, and specifically Aeroflight SQL, is a communication protocol for, hey, how do I get access to data? Now, one of the things that people don't realize about Aeroflight SQL, unless they go look at the spec closely, is that Aeroflight SQL allows you to communicate SQL, but it also allows you to communicate Substrate plans, okay? And so what we expect will start to happen is that you'll see an abstraction of, hey, I have an Arrow compute service built on Aeroflight SQL and Substrate, and I can use that Substrate compute service to be able to submit operations, and then there will be many systems that support that. And so going back to the question, I don't remember who asked before, but the question about who's going to do this as adapter, who's going to actually make this I think it was Anders, asked a question about who's going to make this native, right? And is Snowflake going to make this native? And I'd say that no, Snowflake is probably not going to create a Substrate compute service to access Snowflake. Someone else is going to have to do that, right? But vendor X, who wants to get more workloads and is not the incumbent that feels more comfortable in their position, is going to create a Substrate compute service, because if someone makes something work for a Substrate compute service, they're like, hey, I can get some of those spends. Because one of the things that's been historically a big challenge in this market is the fact that in order to generally be successful as a compute engine is you may have to become a general purpose compute engine, which means you have to support all workloads. And so specialized engines will start out specialized and they'll say, I'm not going to do joins, right? And we saw this with BigQuery as an example, right? They said, hey, we're not going to do joins more than, I think, 8 megabytes or something like that. But guess what? People start putting the workloads on it, and then they need bigger joins, and they're like, hey, add bigger joins. And so what happens is that these data platforms take a long time to create because they need such a breadth of capability, right? When you're going after Teradata as a replacement, Teradata has a huge amount of functionality, and that's what people like Snowflake and Databricks are largely doing, is they're doing Teradata takeouts, or at least some of what they're doing. And so there's a huge breadth of functionality, and you have to be general purpose, because when people say, hey, it's this API, let's say SQL, they're like, well, I should be able to do anything in the world, and it should work, and it should be performant, which is a lot of different capabilities. What I think is going to be the opportunity moving forward is that you won't have to build a generalized compute engine in order to take advantage of doing things, right? Because right now, organizations have to say, I'm going to move this workload from a general purpose compute engine to a special purpose compute engine. And that's a very expensive proposition. And it's something that only very large organizations do, right? So like I would describe, Pinot and Druid as examples of specialized compute engines. They're really good at some stuff, but then they don't do a bunch of things that, general purpose compute engine does. So people use those things, but they have to pick individual workloads where they can have a huge amount of benefit. Now you talk to those communities and you see them getting pulled in the same direction, which is people put the workload there, and then all of a sudden there's a pull towards general purpose. And so once you have an abstraction like Aeroflight SQL and Substrate, it starts to allow you to make those decisions not at the workload level, but at the query level. And that's really where compute portability becomes much more powerful, is that I don't have to make these decisions at the workload level. I can make those at the query level. And so if a certain subset of queries can take advantage of Pinot and its really great capabilities, then great, like I'll send those queries over there, but I shouldn't have to port my entire workload or use case over to Pinot or Druid to take advantage of those things.
Great, thanks. Christian asked a question about catalogs. So I'm going to ask the question and then share a little bit about it. But Christian's specifically interested in the impact of catalogs and how good each of the engines are reading, writing stats that will make the files truly interoperable. Do you worry that the devil will be in the details around the writers not creating reusable statistics? I especially think of folks looking to Xtable to help bridge certain gaps. Just as a side note, I did post a response that that Jacques provided, kind of assessment of table formats and what was going on and things like that early on this year. I'll put that in the chat as well. But just curious, Jacques, what you would say to that question?
Yeah, I mean, I think I'll say that at the high level, whether you're talking about data portability or compute portability, that the devil is in the details. I completely agree with that. And there's interesting dynamics here, right? Which is that like, how native are people to these systems, right? Like, and as Matthew mentioned, I kind of did some analysis against this, right? And it's like, as an example, when Snowflake says they write Iceberg tables, there's actually a really great long article talking about how they do this, right? And it's a conversion process. Now it's not converting the data; they write the Parquet files just like you would expect. But then they write the metadata to their internal foundation DB, or I think it is. They write it there, and then afterwards they then write also the Iceberg manifests. Okay, and this has certain constraints about how that system works. And it is true that like there's nothing that stops an organization from building up additional metrics that are both in the files and sort of sidecar files that exist next to the primaries, right? And there's been some work inside the Iceberg community, as an example, to build those things up. One of the things that Delta did early on, right, was that created additional data representations that could be part of the data set that weren't entirely open source. Now they are now, but that's a dynamic that exists. And so I think the devil is in the details. But here's the interesting part, right, which is that the challenge around portability is a long tail challenge in that historically, if you're trying to migrate something from one place to another, you have to figure out how to make all of it work. Okay. What's interesting about the SaaS world that we live in today is it's not an all or nothing kind of world. And what that means is that there may be a long tail of small things that are different. Like, hey, this one query benefits hugely from that particular performance optimization of statistics that Snowflake saved that is not standard and that, say, Databricks couldn't understand, right? Those things will probably exist. But what we have seen is that the things that are most important and most commonly used are things that won't exist in that category. It's going to be the edge cases and the rare situations that are going to be in that category. And because we're in a SaaS world, it means that I can get a huge amount of value in the general cases, even if there are edge cases that aren't as compatible. I can just leave those on that underlying platform, right? And so compute portability doesn't have to be 100% portable for it to be very, very useful and very, very impactful to your bottom line. And that, I think, is a key thing to think about is that we shouldn't think about this as migration. We should think about this as portability at a fraction of total capability. Because you can get a huge amount of, it's not an all or nothing kind of thing. And that is very, very impactful, even if there are details that are painfully incompatible.
Okay, great. I'm going to ask Jacques, if you could look at the Q&A session. There's a question there from Kyle, and there was a conversation between Kyle and Alex. While you quickly review that, and other people, if you can see that, you can bring up the Q&A section. You can see that open question. You can see there's some good conversation back and forth. I'm going to ask Jacques to give his opinion on that in a moment. While he's reading that, I'm just going to remind you that the recording will be made available. We will send that out at the end. Please feel free to share it with coworkers, colleagues, anyone else you think is interested in this topic. And definitely love all the interaction and questions we're having. Keep them coming. If you do need to drop off, that is completely fine. Thank you for joining. But we'll continue answering any questions we have until the top of the hour. So with that, Jacques, any thoughts on the standardized compute? How does it pay? What is the plan?
Yeah.
What does gluten mean in all of this?
Really important, and maybe I didn't do a good enough job of reinforcing this. Yeah. So the technologies I talked about, like Substrate and Iceberg and Arrow, are all open source technologies that anybody can use. And so they are not trying to profit off of this in any way, right? Like, open source is best when it's a technology that many people would benefit from and nobody wants to build. And then I think of Arrow as a good example of that. I think Substrate is a similar good example, which is that, like, none of us think of it as, I mean, I don't think of it as something that's a competitive differentiation. I think of it as something that, like, this is something that allows other things to occur, which is where I think there's a lot of interesting things. And I think Alex covered a lot of the points there. And so it's not a commercial endeavor at all. And, yes, I work at Sundeck. We have commercial interests at Sundeck, but Substrate is an open source project, and it's very much about driving this future. And so, will there be places in the future where these dynamics will start to turn into commercial opportunities? For sure. But right now, this focus is very much on trying to start to build the way that these different Legos fit together.
Right. Shriram's another question. How much is too much for such composable data systems? Today, I may have one vendor accountable for my business. Now, in a composable data system, I have one too many composable parts, which means the interoperability on data types and precision matters most.
I think it's a great question. And I think that there's this curve, right, which is what are the benefits? Like, if you think about, like, why do I want decomposable systems, right? And it's all about benefit. Like, nobody should adopt decomposable systems because it's cool, right? But if you find yourself, for example, in that dilemma, right, where you have data stored in one system, but you have a group of users who want to work in a different paradigm, right? So you have that issue where you're like, hey, how do I fit these things together, right? So that's one situation. The second one is that, like, hey, I have compute capacity over here, which is much more affordable or makes more sense for me than compute capacity over here. Should I like to move these things around? Or maybe I can't hit the latency mark, right? Like, one of the things that, people don't talk that much about is that a lot of these OLAP systems, right, their target latencies are hundreds of milliseconds or more, right? If I'm working on a very, very high performance dashboard, right, and I remember working at one point with Apple years ago on an executive dashboard where their target latency was, I think, 40 milliseconds or something like that, right? There's only certain technologies that can hit that benchmark. And so decomposable systems may allow me to get there in a much more efficient manner, even if I'm a smaller company than someone like Apple, who can just kind of glue all this stuff together and throw a bunch of engineers at it. And so to me, it's not about, hey, I should just adopt decomposability for decomposability's sake. No, what's going to happen is we're going to turn these things into more and more mature things so that the effort to adopt and the benefit is more in line. The reason that, Meta already is using decomposable systems to solve their Presto and Spark workloads is because they spend so much of compute that it's worth a huge amount of headache to do it. They had to build their own compute kernel. I mean, that's a huge amount of investment, but it makes sense because they're spending, hundreds of millions of dollars a year on that compute. If you're a smaller company, it's not going to make sense to build Velox, right? And what's happening now is that you see maturation. And as maturation occurs, you're going to say that the cost to actually benefit from these technologies goes down substantially until it starts to make sense for you as a smaller organization to make that choice, right? And that's true with the table formats, right? Like, Netflix had such a problem with tables that they built a table format, right? They built Iceberg. right? Because they had that much pain, right? Not everybody's going to build Iceberg because sure, they have pain, but the amount of cost to build something is way beyond what the pain was. And so the same thing is going to happen here, which is over time now, Iceberg is accessible through all of your common tools, and it's something that's really easy to use, and you don't have to spend a lot of engineering, data engineering, software engineering dollars on it. And I think it's the same for these other things. This is that as decomposable systems gets exposed in more and more mature ways that are more accessible, then all of a sudden it isn't about like, oh, this is too many, I'm gonna have to figure out these details. No, you're gonna know that this is compatible, it does these things, it's gonna know how to do those things automatically, and it's gonna be a little checkbox or a little choice. It's not gonna be a giant software engineering undertaking, right? Which it is today, right? Like if you want to compose, Substrate with Calcite, with Spark, with the Velox or Data Fusion, you're going to need software engineers to solve that. But that is this moment in time. And in the future, that is going to become easier and easier through maturation of those technologies and vendor solutions that sit on top of them.
All right, great. This will be our last question. Do you see tools like DBT trying to position themselves as orchestrators of arbitrary compute? They already support SQL or Python models, but based on the capabilities of one single vendor.
Yeah, I think it's a great question. And I think for sure, I think that there's tickets. I think Anders was on here previously. I think maybe he's still on here. And he can respond to that because he opened a ticket in DBT several years ago, which talked about this idea of abstraction of compute. And so I absolutely think that that's an opportunity for tools like DBTs to say, hey, I'm working in this paradigm of how I interact with data, and I want to introduce new ways to do that. Like that's actually part of the inspiration of Substrate, right? Is LLVM. So if you're not familiar with LLVM, it's a low-level virtual machine. It's used in compilers. It came out of, I think, Illinois and Apple. And what's really cool about it is it created this thing called the LLVM IR, which is an intermediate representation of how you describe a program. And what's powerful about it is that when this was created, it allowed there to be innovation at different levels without as much work, right? So right now, if you want to do a really cool hash join and sell that to the world, you've got to build a generalized compute engine to do that, okay? And if you want to build a completely new API of how to work with data, you generally speaking are going to have to figure out a way so that the API can be converted into every existing compute engine because everybody's using their own compute APIs, right? So I'm already using SQL or I'm using a data frame API or whatever, and I want to create this new pattern of how people interact with data. I've got to do all of the hard work, right? If there can be an intermediate representation in data the same way that there is an LLVM, you're going to see the same kind of innovation. So in LLVM, we started to see once that LLVM IR started getting created, what we saw was a huge influx of new programming languages, new ways to interact with data. And that was a powerful shift, as well as a new way to interact with backends, right? So if I wrote WebAssembly to work with LLVM IR, that means that every language that can now be compiled to LLVM IR can now work on top of WebAssembly. It's a very powerful paradigm. And so I think that the same thing is true with DBT, right? Is that as tools like Substrate make it easier to abstract the front, which is what the users are doing, from the back end, which is how we actually execute those things, it allows them to start to become much more engaged in creating new ways and new paradigms for interacting with data.
Great. Well, we are at time. I'd like to thank everyone for joining our session today. Thank you, Jacques, for the material that you presented. And thank you to everyone in the lively Q&A we had. Loved the comments from everyone on that. That was really awesome to see. We hope to put on more of these sessions over time on interesting topics. Feel free to reach out if there's topics that you would like to see in this kind of space and what we see that's going on, what questions you have, and we'll do our best to put something together to help make sense of what's going on. And with that, the recording will be sent out, so stay tuned for that. And if you want to learn more about Sundeck, definitely check out sundeck.io. We'd be happy to kind of show you what we're doing that's building for this world that we kind of shared today. And with that, I would like to say thank you for joining and have a great rest of your day.